EMSNOW. I'm joined today with Chris Nash, Product Manager of the PCB Assembly Materials with Indium Corporation. Chris, welcome. Thanks for spending a little time with us today.
Thank you, Eric.
Yeah, listen, before we begin, why don't you give a brief introduction of yourself and Indium Corporation for the benefit of our audience?
Sure. So my name is Chris Nash. I'm a product manager for the PCB Assembly Materials. I've been with Indium Corporation for 15 years. I think a lot of people at Indium have been there quite a while. It's a great company to work for, and it's a great company to work with. We've been around since 1934, and we're primarily focused on electronics and solder. So whether that be the semiconductor industry or the PCB assembly industry, and we also have some compounds and metals based businesses as well. But really, we cover the soldering world from nuts to bolts.
Good. Well, now I wanted to speak to you today about low temperature solder specifically, but before we get into that, why don't I just ask you to share kind of, obviously we've been living through some interesting times here in 2020. So kind of what's the impact of the pandemic been on the operations there at Indium?
Well, I think it's slowed us a little bit. I think not Indium particularly, but the entire globe has been slowed by the pandemic. I think we saw it first off starting in China, where the China market slowed to a complete halt. But they got going pretty quickly again, and then Europe and the Americas really took almost a nosedive. A lot of automotive companies completely shut down shop during the pandemic, especially in Europe. And I think that was unsafe practices in the workplace that really drive that challenge. So really what we're seeing now is a resurgence of business. People are opening back up most people are opened back up at some capacity. And we are really looking forward to the growth in the industry. I think we're going to continue to grow in the electronics segment and in soldering. Everyone needs solder, and everyone is trying to use electronics more and more and more.
Yeah. No, absolutely. It's just which sectors that need it is the one that's kind of been, as you just indicated, with automotive, it fell off, but others are certainly picking up in the process. Let's start then on the actual low temperature solder. And why don't you maybe start by giving a description of the development or the history of low temperature solder development?
Sure. So I think low temperature's been around for quite a long time. Indoi number 1, which is a indium-based alloy, it is a low temperature alloy, but it was our first alloy that we developed as Indium Corporation way back in 1934. So low temperature solders is not something new to the industry. I think a few years back, Intel started talking about low temp more and more, and was trying to push the industry, and it still is trying to push the industry into low temperature. And I think that's really because their processors were getting smaller and smaller, thinner and thinner. They were going with coreless processors, and the warpage of those components was increasing with the thinness of the components. So that's really been the big driver in the industry, thinner components, coreless components, that has really pushed towards low temperature solders as of recently. Now, there are a lot of other applications out there, whether it be step soldering applications or just thermal management applications where low temperature can play a significant role and has played a significant role over time. For instance, the step soldering application might be attaching an RF shield to a circuit board, whether it be for a cell phone or a computer. That's going to need a low temp process because you have already made all the other component connections to the PCB with your SAC solder or your tin lad solder, whatever you're currently using. So you don't want to disturb any of those solder joints that have already been formed. So that's where kind of a low temperature came into play. Now, the one thing with low temperature that you really need to take into account is you have a bismuth and indium. Those are the two elements that really lower your temperature of solders, tin-based solders. So bismuth by nature is a very brittle element, and indium by nature is, well, it's a semi-precious metal, so it's going to be a little more costly than your bismuth option or your SAC option or tin lead option. So it's kind of a pick your poison scenario that the industry is faced with. Do you want something a little more expensive, or do you want something with less reliability? And with reliability, it's mostly that we're looking at drop shock reliability. So any handheld devices, you're really going to want that drop shock reliability. Now, because bismuth is cheaper than indium, most people lean towards using the bismuth or bismuth tin or bismuth tin silver options until fairly recently when Indium developed the Durafuse LT. Now, the bismuth tin option is a great option if you've got TVs or thermostats that are hanging on the wall and they're never going to be dropped, right? But when it comes to handheld devices, one drop and the bismuth joints would practically break or will break in that type of scenario. So people are forced into other alloy options.
Okay, and you mentioned silver in there within the indium. So is that? But as I understand it, silver is stronger, but it also has a higher melting point then too, right? And obviously cost.
Yeah, and cost is, we are seeing with the pandemic, again, you know, gold is skyrocketing, precious metals are skyrocketing, so silver is also skyrocketing. And I don't know if that's going to withstand the test of time, but, you know, right now we're seeing an increase in silver, which means that any silver that you put in the alloy is going to raise your cost, similar to indium, but indium right now is relatively cheap compared to where it was maybe 15 years ago or something, you know. So it's all metals markets, and you know, you really can't look at the metals market too much because it's going to fluctuate and you're never going to guess where it's going to end up.
Right. Kind of like the stock market these days. So.
Oh yeah. For sure.
Good. Listen, why don't you give a sense of the benefits of low temperature solder from both a technical but also an environmental perspective, because both are, it's the balance of those that's the challenge and the importance, right?
Right. So I think a lot of people are looking at low temperature from a cost standpoint because the bismuth alloys are relatively cheap, especially compared to SAC or tin lead. They are a little bit cheaper in cost, but that doesn't necessarily mean that you're going to see a cost difference on the solder paste price. We do have economies of scale to take in place where the majority of the world is still using tin silver copper. So, you know, all the solder manufacturers out there are running high volume with Sac-05. So, you know, a cost of bismuth tin is going to be a little bit higher from a processing standpoint because you don't have the economies of scale. But, you know, from a cost standpoint, there's also drivers with reduction in energy usage. So if you run your reflow oven at a lower temperature, that means you're going to save some electrical costs, for instance. And there are some benefits from the technical side as well, where the bismuth, any bismuth in the alloy will aid in wettability of a material. So it'll help with wetting and spread. But a lot of times people are looking also at flex polymers and being able to use certain flex polymers with lower temperature solders where they're not able to use those specific flex polymers with the high temp SAC or even tin lead based solders. There's a lot of other benefits as well to going to low temp, but I think a lot of them are in the step soldering applications, you know, the RF shields, the rework applications, avoiding solder squeeze out with underfill materials. So a number of reasons why people are choosing to go to low temp or are looking at low temp options as a possible solution.
Now, and where Indium plays in this is, as you've referenced it a few times, is the Durafuse LT, is the product that is the low temperature, thus LT, on the Durafuse. Why don't you tell us about, and was introduced already, so it's not a new release either. So.
Correct, yep. So Durafuse LT is a really exciting new technology that Indium has developed, and we're seeing a lot of positive results with the material right now. It is a low temp alloy solution that allows for better drop shock performance compared to the bismuth tin silver. You know, I said before, bismuth tin silver or even bismuth tin alloys are going to give you, you know, 1 or 2 drops and your assembly is going to fail in the field. Whereas Durafuse LT is really close in performance, if not better in performance than the SAC 305 alloy from a drop shock standpoint. So it's really an unprecedented alloy development that Indium has come up with and is commercially available. And really the technology incorporates 2 different powders. You have a low temp powder and a SAC powder mixed together in a solder-based form. So the low temp powder starts to melt at around 100, well, it's technically 113 degrees C, but it really doesn't start to melt until about 170. It starts to wet the surfaces and it starts to diffuse some of the tin from the SAC powder into the liquidous alloy. And what that does is it changes the composition of the alloy slightly so that you have slightly higher melting point after the first reflow. Not much, it's a few degrees. So you're able to reflow at 200 degrees C, 205 degrees C, or 210 degrees C peak temperatures, but you'll need a special profile to allow that technology to work properly. So it's a really, really unique and beneficial alloy system that Indium has developed to fill kind of a void in the low temp realm where they need high durability, high drop shock performance, but at a less costly price point.
You know, as I hear you speaking, it makes me wonder, how do you then consult, does Indium then consult with the manufacturing partner, the clients who are buying and using the solder as to the appropriate solder to be used in particular product and things, depending on what's being manufactured?
Absolutely. We have a world-renowned tech support team that spends night and day, literally night and day, talking with our customers, talking with the EMSs, and trying to really pick the product that's going to be best suited for the application. And that may mean the alloy. It also may mean the flux vehicle or the metal load or the mesh size as well. It's not specific to, you know, alloy in this case. You really need the perfect solution for the application that you're working on. And Indium's tech team, there's really no better tech team in the world than Indium's.
Okay, nice endorsement there. Well done, Chris. Well, and that opens the door then. You've mentioned this a few times, but as far as are there specific sectors in which the low temp solder is more applicable? You said something like if it's a thermostat on the wall that's not going to fall. Are there ones that it's more applicable to and ones that it wouldn't be?
Yeah, I think in every industry there's a need for low temperature, and I think it's really just digging out and understanding what the application is. For instance, the thermostat on the wall, the smart thermostat, or the TV that's on the wall, they could handle a bismuth tin silver and probably come to some cost benefits with the bismuth-tin silver or the bismuth-tin alloy, because there's no drop shock performance requirements. Other low temp applications, you might have some in the automotive realm with more of a step soldering application. Computing right now is really the one that's driving the need and the demand for low temp. I think it's because of these high warpage type processors. They're looking to reduce warpage on those processors and provide a solution in the low temp realm. But you know, throughout the entire industry, what doesn't matter what market segment that you're building for, there could be and is most likely a need for low temperature with one application or another.
Okay, very good. Now, just kind of in closing here, I'm just wondering, how do you see 2020 kind of playing out? This is historic times. Electronics still seems to be doing quite well. We see the various forecasts, you know, not as optimistic as they were at the end of 2019, but then it's starting to get better again in second half and possibly into 2021, 2022. How is it in your industry? How do you see 2020 playing out?
I think 2020 is really going to end strong, and that's my personal gut feel on things. I think we've seen a resurgence of business and well, since probably mid-July, I think things have started to turn on for us. China is really kind of ahead of the game, I think, and Southeast Asia is a little bit ahead of the game. They started turning on probably, you know, May, June timeframe, and then Europe and the Americas have really started to turn on in the July timeframe. But I think there's going to be a lot of pent-up demand. And I think there's a lot of backlog that that our customers are going to need to fill because people are still buying stuff. The economy seems to be great. The stock market seems to be doing well right now. And I think people have confidence, you know, buyers' confidence and consumer confidence is still pretty high. So I think there is going to be some pent-up demand for these factories that have been out of business or temporarily shut down for a number of months. I think they're going to have to get back and running and moving into the Christmas build season. We usually see a ramp in electronic manufacturing right around this August, September, October timeframe. So I think, you know, it's hard to say how things are going to pan out, but I have I'm pretty confident that things are going to start to turn on, come back. You know, who knows what's going to happen with the U.S. election? That may affect how things go too. So, but you know, automotive is going to be down for a while. I think people are still not buying cars, but the consumer items, people are still buying. 5G is still a big driver in the industry. So there is some positive growth from a number of market segments within the industry. It's just a matter of which industry you're focused on.
Yeah, exactly. You know, we saw the PMI this week come out at, you know, at 54, which was a great here in the Americas, right? And you know, I think you're right on automotive. I saw a headline where Hertz has to sell 110,000 vehicles by the end of the year to kind of stay.
Yeah.
So maybe not a lot of new vehicles being built with that inventory being sold off. So
I think less people are traveling too, so who knows what the airline industry is going to do, and the rental business, the car rental business, not a lot of people are traveling, so of course they're going to be hit by it and hurt by it.
Exactly right, exactly right. Well, Chris, I always enjoy speaking with Indium because you guys are involved not, you know, in all sectors and everything in electronics, because you're kind of the lifeblood of it in a very real sense. So so thank you for your time today. Thanks for sharing your thoughts and your insights. I'm sure the audience appreciates it. And hopefully we catch up again maybe before the end of the year.
Sure. I'd love that, Eric. Thanks a lot.